We told you previously that during an upgrade, the CPU is a vital resource, and it means much more to the upgrade performance than adding more memory or getting faster disks. We made an experiment. We provisioned a bare metal system in OCI. It had 16 OCPUs, a lot of memories, and super fast NVMe disks. We created a container database with 52 PDBs. CPU count was set to 32, 16 OCPUs means 32 CPU count, 100 GB of memory for the instance. The database had all 17 components installed, and we tried an upgrade from 12.102 to 19. This is what happened. This is a graph of the CPU utilization for the 4 hours and 8 minutes that it took for the upgrade to complete. Since CPU is a vital resource, we would love to see it used as much as possible. So you could actually argue that everything above the red line is waste, unused potential. And ideally, the utilization should look something like this, constantly at 80 or 90%. But that's not realistic, because we learned previously that some of the phases in the upgrade is serial, and sometimes some of the workers are idle because they're waiting for the next phase to start. First, we have the pre-upgrade checks and fix-ups. One of the recommendations that we give you is that you should gather fixed object and dictionary statistics in advance of the upgrade, so you don't have to spend precious downtime on gathering statistics. If I follow that advice, I end up with something like this. It saves me 12 minutes on the upgrade by gathering dictionary and fixed object statistics in advance. The CPU utilization is still, I would say, average, but I can save some time by gathering stats in advance. The next phase is upgrade of CDB $root. The recommendations I can give you there is to try to remove some of the components, but that might actually be hard, at least in CDB $root, because you have to remember that CDB $root has to be a superset of the amount of components that you have in all the user PDBs. If you have one component in use in one of your PDBs, it has to be installed in PDB $root. In addition to that, you can ensure that as much parallel processes are assigned to the upgrade of CDB $root as possible. We learned previously that it's 8. And when you use auto upgrade for the upgrade, it'll automatically ensure that 8 parallel processes are used for the CDB $root upgrade. But we can still try to see what happens when we remove some of the components from CDB $root. And you will end up with something like this. In the lower graph, we redid the same upgrade, but we removed all the components except 3. So there's a dramatic effect on the upgrade runtime, and it knocked off 13 minutes. So that's quite good to consider, I would say. In the next phase, we are upgrading PDB $seed and all of the user PDBs. I told you previously that you should scale a multi-tenant upgrade by allowing more PDBs to be upgraded at the same time. And you can see here from the CPU utilization that even though it's running with 32 parallel processes, I would say it's only average, and it's probably around 50% or so. So there's really a lot of unused potential. So let's see what happens when we change the total amount of parallel processes that are available for the upgrade from the default of 32 and now into 54. And the effect is dramatic, I would say. We get much better CPU utilization on the lower graph, where we have 54 parallel processes, and it saves 26 minutes on the upgrade runtime. So we are actually overloading the system here. We are allowing more parallel processes to be used by the upgrade, because we know that sometimes some of the parallel processes are idle, either because it's a serial phase or because it's waiting for other workers or parallel processes to finish. So I would say you can actually overload your database upgrade by allowing more parallel processes than you have CPUs in your system. In addition to that, you can also look at whether you can remove components from your PDBs. I did the same here, and I removed all components from the database except 3. The overall runtime of my upgrade saved me 48 minutes. And if you include the 30 minutes it saved on $root, I could actually save an hour, almost 25% of the entire upgrade by removing components from the database. And the last phase of the upgrade is the post-upgrade checks, which includes the PL SQL recompilation, the utlrp scripts. And that's actually very good parallelized already. So there's really not much to gain in this phase. And the only recommendation I could give you is to postpone the time zone file upgrade. So the conclusion of this little experiment is that you should gather statistics in advance. You should allow more PDBs per cycle by overloading your upgrade, I would say. You should allow more parallel processes to be used than you have CPUs in your system. How much? It depends. Each database upgrade is really different, so you have to go home and try it on your own databases to find a number that makes sense to you. And finally, really, you should get rid of those components in your database that are not in use. And you saw the effect on the numbers here. Almost 25% of the upgrade could be saved by lowering the amount of components in the databases.